Welcome back once again to the Mickey Maths class, a channel solely dedicated to demystifying mathematics, making complex problems easy. Now, we have been looking at the simultaneous linear equation, and in our previous lessons, we looked at use of elimination method, use of substitution method. Today, we'll be looking at solving simultaneous linear equation using the matrix method, specifically using what they call the Cramer's rule. So, solving it using the matrix method. Now, I will show you how to do it. Let's take an example. Example 3x plus 2y equals to 18, and we have x, 2x minus y equals to 5. These are the two simultaneous equations we have. Now, when we are solving it using matrix method, the first thing is to put the simultaneous equation in matrix form. Now, for me to put it in matrix form, I bring out the coefficients. The coefficient of x here is 3. That means what is standing in front of x. That's the coefficient, that's 3. What's the coefficient of y? 2. Now I go to the second equation, simultaneous equation. What's the coefficient of x here? Is 2. The coefficient of y here is minus 1. Minus 1. This is a 2 by 2 matrix. Then we have a matrix of our x, of either x and y, equals to our matrix of the constant terms. That's the first thing. When you are solving simultaneous linear equation using the matrix method, you arrange the simultaneous equation in matrix form. Now, after you've done this, the next thing to do is to look for what we call the determinant of the matrix. The determinant, written by this determinant of this matrix, this 2 by 2 matrix. And how do we do that? This is 3, 2, 2 minus 1. We multiply the number in the leading columns. That is, the determinant here will be 3 times minus 1 minus 2 times 2. 3 times minus 1, that's downwards, upwards. That's how we multiply the matrix. 3 times this minus this times this. So 3 times negative 1 is minus 3. Then 2 times 2, you have 4. So minus 3, negative 3 minus 4 is minus 7. Minus 7. So our determinant is minus 7. Now the next thing to do after we found the determinant is to look for the determinant of x. How do we mean? The first thing, this column represents x. Replace the numbers here by the constant, the numbers in the constant matrix. That means 18 and 5, I'll replace 3 and 2 by 18 and 5. Find the determinant. Determinant in order of x. So, delta x will be, now I form a 2 by 2 matrix also. A 2 by 2 matrix. And this column stands for x. So I replace the values there. 3 and 2 by 18 and 5. So that's 18, 5. Keep this one is still there, constant, 2 and minus 1. So I find the determinant, this times this and this times this. So this is 18 times negative 1 minus 2 times 5. This is minus 18 minus 2 times 5 is 10. Minus 18 minus 10, that's minus 28. That's my delta x. determinant in the order of x. Now the next thing, I do the same thing for my y. Or before we do that for y, now let's find our x. Our x is equal to delta, the determinant in the order of x over the main determinant of the 2 by 2 matrix, which is equals to our delta x here is minus 28 over the determinant here, that's minus 7. Minus, we cancel minus. 7 here 1, 7 here 4. So our x is equals to 4. We'll do the same thing for y. If we want to find our y, we'll do the same thing. Now let's look for y. This is our matrix. Don't forget, this is the column for y. So I replace it by the constant terms here, just like I did for x. So determinant in the order of y. So I have my 3, 2, then I replace this one, 2 and 1 minus 1 by 18 and 5. So this is 18 and this is 5. Now let's multiply downwards, upwards. Multiply the leading, the number that is leading, or the leading coefficient, I mean. So this becomes 3 times 5 minus 2 times 18. Are you still there? Okay, let's continue. So 3 times 5 is 15. So this is 15 minus 2 times 18. That's what? Minus 36. Now you have 15 minus 36. This is minus 21. So determinant of y here is minus 21. So how do we get our y? Our y will be equal to determinant of y over the main determinant, which is equals to minus 21 all over the main determinant here was minus 7. So that's minus 7. Negative will cancel negative. So 7 here 1, 7 here 3. So therefore, our x is equals to 4 and our y is equals to 3. Our x equal to 4 and our y is equal to 3. So in our previous classes, we learned how to check. So you can apply it. Let's check if whatever we have solved is correct by imputing the value of x into these equations here and the value of y into it. The left hand side and the right hand side must be equal for you to know that what you've solved is